Hey there, it's time to look at some perfect square trinomials. What is a perfect square trinomial, you say? It is a trinomial that comes from squaring a binomial. There we go. The A term and the C term are both perfect squares. The C term must be a positive number. That's a really important fact. The C term must be a positive number. And the B term, it's going to get confusing for a second, is double the product of the square roots of A and C. It'll make sense when I show you. The answer can be written as one binomial squared because it's the same binomial twice. We've seen a couple of these here and there, but never really knew what they were. So the C term is always positive. So this is a perfect square, this is a perfect square, and the square root of x squared is x, the square root of y squared is y, and their product, x times y, doubled, which means times 2, is 2xy. There you go. Notice that the B term is a plus here, the parentheses gets a plus here. We have almost the same problem here, but this time the B has a minus, and therefore a binomial gets a minus. Let's just see how it looks. Here we go. I got 5 of them here for you. One of them is extremely easy. Jackpot. Take a look at that C term. The C term is a negative. Even though that's a perfect square, this is going to cause a problem. We'll take a look at that in a minute. First, let's do the first one. Is m squared a perfect square? Sure is. Is 64 a perfect square? Sure is. Is the C term positive? Sure is. So, I'm going to make one parenthesis. I'm going to take the square root of the A term, that's m, the square root of the C term, that's 8. Because the B is a positive, this gets a positive, and this binomial is squared. Because that means, if you remember when we squared a binomial, you had to write it twice. So it'd be m plus 8 times another m plus 8, if you were to FOIL it. This is the long way, but that's okay. So m times m would give me m squared. The outer and the inner are both equal. They're both 8m. That's why we double it to get 16m. And then the last are 64. All right, so that's how we checked it. You just got to trust me on this one. 4y squared minus 20y plus 25. Is the C term positive? Yes. Is the A term a perfect square? Yes. Is the C term a perfect square? Yes. All right, so I can make one parenthesis. I'll take the square root of 4y squared, 2y. I'll take the square root of 25, 5. The B term is a negative, so this is a negative. If I multiply 2y times negative 5, I get negative 10, and double that, I get negative 20y. Square my binomial, there's my answer. It's really that simple. Is the C term positive? Yes. A term, perfect square, yes. C term, perfect square, yes. All right, let's make one binomial. Take the square root of 16p squared, 4p. Take the square root of 9, 3. B term is positive, parentheses is positive. Check it out, 4p times 3 is 12p, doubled times 2, 24p. Jackpot. Square it, and I've got an answer. Is the C term positive? Yes. Is the A term perfect square? No. Is the C term perfect square? No. But does this trinomial have a GCF? Always look for a GCF first. The GCF of this is 2. That leaves me 25q squared. Now I got a perfect square. Minus 30q. The B term does not have to be a perfect square, just A and C. In fact, the B term will almost always not be a perfect square. That's really rare. Plus 18 divided by 2 gives me 9. Perfect square, yes. My C term is positive. My A and C are both perfect squares. So I'll make my parentheses. The square root of 25q squared, 5q. The square root of 9, 3. B term is negative, parentheses is negative. 5q times negative 3 is negative 15q, doubled, negative 30q. Square the parentheses, and don't forget to bring down that GCF too. There's my final answer. Here's that trouble guy. Perfect square, yes. Perfect square, yes. Positive, no. Which means this is not a perfect square trinomial. And in fact, this one specifically is prime. You're going to run across that a couple of times. They're going to try to confuse you by setting everything up to make it look like perfect squares, but a negative C term means no go. You might be able to factor it otherwise. In this case, not so much. All right, let's see how it applies to equations. This makes equations really easy. First of all, your equation has to equal 0. So I'll do this one first because it equals 0. Great. Is the C term positive? Yes. Is A a perfect square? Yes. Is C a perfect square? Yes. All right. That means that I have to take the square root of 25k squared, be 5k. Square root of 4 is 2. B term is positive. Parentheses is positive. Squared equals 0. That means I'll have the same parentheses twice. That means that when I use my zero product property, I don't get two answers because they're the same binomial. I just get one answer. So I only have to solve it once. 5k plus 2 is equal to 0. Or 5k plus 2 is equal to 0. Same thing. Subtract 2, divide by 5. And k is equal to negative 2/5. Only answer. Over here does not equal 0. So my first step, add 49 to both sides. 4k squared minus 28k plus 49 equals 0. Hey, check it out. Now my C term is positive, and it's a perfect square. A term is a perfect square. So let's factor it. 4k squared's square root, 2k. 49 square root, 7. B is negative, parentheses negative. I didn't check this one. I'll have to check this one. 2k times negative 7 is negative 14k. Doubled is negative 28k. All right, there my factor is good. So that means that my only factor, the same one both times, in my zero product property is equal to 0. Add 7, divide by 2, and k is equal to 7/2. You don't have to use this shortcut. You could factor all of these the way we did before with either slide, divide, slide, or guess and check, or with A times C and then factor by grouping. It would work, but if you recognize the perfect squares, it makes the factoring easier. It's just a shortcut. This is a specific trinomial shortcut. All right, get to work. Have fun.